What I'm going to be doing in this class is first I'm going to chat a little about what are analytic functions. What's the concept here? What's the advantage? Why are they good? Why do we have them? And the whole idea behind that is to show you their capabilities so you can make a decision where in your organization, where in your applications you can use these sorts of things. Once we have the basics for what that's all about, we're then going to go into the syntax, and we'll start simple and we'll build on the syntax and give you many, many different examples and show you all sorts of possibilities on how Oracle Analytic Functions can make your life easier. So that's the goal. Okay, let's start off. The first thing to know about analytic functions is this is not something that's brand new. This has been around for many years with Oracle. Oracle introduced this whole concept way back in Oracle 8 with 26 different analytic functions. And what are analytic functions? We'll get into that coming up in a little bit. And as a matter of fact, this was so well received that it was actually added to the ANSI standard back in 2003. So it's an ANSI SQL standard now, and Oracle has had it way before that. Even in Oracle 11, they have added some new analytic functions and extended the 26 to over 30 some odd analytic functions now. They made them more efficient, they make it run better, faster, and so on. So Oracle has continued to support analytic functions and expand their functionality. Now, average. You're going to see average, min, max, sum. That's going to look to you a little bit like all your standard analytic aggregate functions, rather. So you'll have your normal aggregate functions, which will be handled appropriately. But these are far more sophisticated, even though you use the same terms. Not only do they have average and min, max, and so on, but they have things like variance and standard deviation and ranking and cumulative capabilities, all sorts of nice features. And it's all those additional features that give us the power of these analytic functions. So we're going to get into the analytic functions, but before we do, I just tell you that basically, do you need analytic functions to get the results you want? No, you don't. Generally, you don't anyway. Generally, there are workarounds. If you didn't have analytic functions to compute all these things for you so nicely, you could have workarounds. There are two general types of workarounds. One is, okay, detail data to your application and do what the analytic function do, but do it in your application. That means you have to do more, not on your database. You've got to double all the data to your application. That's not really what we want to do. The second workaround is use SQL, but use tricks and various different techniques in SQL that could get the same results as you get the analytic functions. There's just really no other way to do it in SQL, but some there is with workarounds. The problem with the workarounds is that it's a workaround. Oracle does not know what you're really trying to do. So you're doing something and you're working around the problem, but because Oracle doesn't know, it just does what you tell it, and it's generally, first of all, much more obtuse, much more difficult to read the code. The problem is it's generally much slower. But with analytic functions, you're telling Oracle exactly what you want. I want running totals. I want ranking. Oracle knows exactly what you want, and it can do it extremely efficiently. So that's the important point here. So we don't want to work with workarounds. We'd rather not have to do that. We'd rather not pass all the data to our application. So Oracle introduced these analytic functions to do it all in SQL. Now, when I say it's much simpler, yes, it's much simpler once you go through a little training, which we're doing here today. In the beginning, you'll look at it. It will be a little bit strange, the syntax, but once you get used to it, it's vastly simpler than the workarounds. Okay, so what do they do? What do the analytic functions do? Provide much easier ways to analyze data. Okay, that's the first thing. That's what we talked about, a much easier way to analyze the data without doing these workarounds. And then what do they analyze? They can give you cumulative totals, running totals, cumulative salary within the department, cumulative sales by day through the month, running totals, okay? They also give you percentages within a group. So if you want to know what is this employee's salary, and then what percent of their department salary does this employee represent? Or what is this salesperson's sales, and what percent of the total division sales does that one salesperson represent? So you can easily do that sort of thing. Now remember, you may be thinking, gee, I've already done this. Yes, you have, but you've used tricks, you've used workarounds, and we'll go over not only the syntax for the analytic functions, but also a couple of the workarounds that many of you may have been using to get it, and you'll see the difference in the syntax, and also it would be much slower using the workaround, much faster using the analytic function. What else can it do? Rankings, first highest, second highest, third highest salesperson within the division, first highest, second highest, third highest salesperson within the next division, and much, much more. Many other analytic functions besides just these. Okay, so that's basically the capabilities, and now we're going to get into some of the details. Okay, so let's get started here. To get started, we're going to take a very simple analytic function, and all we want to do in this one is generate cumulative salary, running totals. And if you look at the last column here, that's exactly what we have. We have running totals. Here we have an employee number, last name, and salary. So that's printed here. And then we're getting the sum of the salary, and this keyword over is the key. Sum of salary looks like a standard aggregate function, but the keyword over is what turns the aggregate function into an analytic function. So when you see sum of salary with the keyword over, you know this is an analytic function. And over has several different options. Well, the one option we're going to look at in this example is over with an order by. The order by says I'm going to order by employee number, and I'm going to sum the salaries by employee number. Since I'm summing them within the aggregate, within the analytic function by employee number, that order, then I want to order my outer query by the same thing, employee number. We're going to see that a lot, where however you do the analytic function, you're going to need to sort the data in the same way. So I'm ordering by EMPNO, so here's my employee number 2, 3, 4, and so on. And if I come over here, I see employee number 2 has a salary of 8, and I'm summing them with running totals, so the first cumulative salary is 8. The next employee is another 8, 8 plus 8 is 16. The next one is 12, 16 plus 12 is 28, and so on. So this is a very easy way to get cumulative running totals. Now let's take a look. I'm going to go over here to SQL Developer, and I'm going to take this little query. This is the query we just talked about, where I'm doing the sum of salary over order by EMPNO. And I'm going to run that, and what do I have? I'm ordering it by EMPNO, and I'm doing my salary, and here's my running total for the salary. Very straightforward. Was there a workaround? How did you do this before? Yes, there was a workaround. The workaround is pretty strange. Here's the workaround. Let's look at this workaround and see what it does. Notice it says I'm selecting employee number, last name, and salary, and this is E1 dot, so my outer query is on the employee table E1. See that? That's my outer query. And that gives me my first columns, my EMPNO, my last name, and my salary. But for my last column, I want a cumulative salary column. Well, the trick that we're using is we have a subquery in the column list. And in the subquery, I'm selecting the sum of the salary from the employee table again, but this time I'm calling it E2, where the employee number for the E2 table, the inner query or subquery, is less than or equal to the employee number of the outer one. So when I get, let's say, employee 4, and I want to get the running total here, It executes this subquery and says sum the salary for all employees with the employee number less than or equal to 4. So I get 4 and 3 and 2. I add up the 8, and the 12, and that's how it gets 28. This was the workaround. Not very nice. This kind of subquery is actually called a correlated subquery. And what a correlated subquery does, for those of you that have worked with it, is it re-executes the subquery for every row in the outer query. So if I have 50,000 employees, this is going to run the subquery 50,000 times to compute this sum over and over and over again. That is going to be vastly slower than the solution with the analytic function. Now this will work. So if I take this, I am going to get the same result, and for these 2 rows it's going to look just as fast. But you got to trust me on this one. This is going to run much, much slower. A correlated subquery is one thing you always have to look out for that can run way too slow. The workaround is kind of difficult to read to figure out what you're doing. The syntax is not so straightforward at all. But once you get the feel for this, this is much more straightforward and vastly faster. So that shows you one big benefit of your analytic functions. Okay, let us go back to our presentation, and let's move on. This was the subquery without the analytic function, the old solution, the old solution which had a subquery in it. Now let's back up a little and say I showed you one example. I showed you an example here that showed sum of salary over with an order by. Let's look at the full syntax of the analytic function. It's got a lot more capability than just that one thing we've looked at so far. And that's what we're going to spend most of the rest of the time today, most of the rest of our hour, going over what's the syntax, what are all the other capabilities. Here's our syntax. First thing is a function name. Well, the function name is a standard function name right here, and that's your min, max, average, sum, variance, rank, dense rank, all sorts of different functions, and they can take multiple arguments, up to 3 arguments. Then the keyword over, and now there are 3 different parts to the over. We've got a partition by clause, an order by clause, and a windowing clause. Each of them is optional, or you need at least one, but they're all optional, so you can put one in, but you can leave the others off. What we did in our previous exercise is we had an over with just an order by, and that gave us running totals. But now we see we can have not only an order by, but a partition by and a windowing clause. The over defines this as an analytic function. That's what makes this thing an analytic function, because the over. And basically what it says is, hey, the function will be applied over a slice of data, some sort of slice of data. And we're going to see how we do those slices of data. How do we slice that data? Well, the first thing is the partition clause. We've talked about the order by very briefly. There's a lot more to go over with that. But let's jump into the partition by clause. So what does this do? The partition by clause breaks the results into groups, into logical groups. And that group could be a day, the value for any column, a department number, whatever we want. And the key here is that the function works on the groups independently. So if I have a partition by, it's splitting things into groups. Well, this is starting to sound familiar. What does this sound familiar? It sounds familiar because we've seen the group by clause with aggregate functions do the same thing. So the partition by clause in an analytic function is similar to the group by clause in an aggregate function. More functionality, but similar. In addition, if we have a partition by clause, it is optional. If we don't have it, the default group is the entire result set. Well, now that sounds even more like a group by and an aggregate function. Because if I said select sum of salary from employee, and I didn't have any group by, Just select sum of salary from employee. Well, there's no group by, so therefore the default group is the entire result set. Same thing here with the partition clause. If there's no partition, the default group is the entire result set. The second part is that if there is a partition by clause, then the function works independently on each partition. Well, it's the same thing with an aggregate function. If I say select department number and sum of salary from employee group by department number, I get a separate total for each department. Same thing here with the partition by. Partition by, it gives separate results for each partition. So let's take a look and see how all of that is done. Here's an example that has a sum of salary again, and I have my over clause, so I know it's not an aggregate function, it is an analytic function. And I'm going to have a partition by with no order by. The last example, remember, had an order by with no partition, and I got running totals. Here, I'm having a partition by, but no order by. So let's see what that does. The last column is the total salary, and what it does is it sums the salary over each partition. It's partitioning by department number. Since I partition by department number up here, then that's going to be my high order sort and my order by. And then I happen to also sort by last name. So my department number right here is sorted. It's my high order sort, so I get all department 1, 2, and 3. For department 1, I get Do-Right and then Washington and Wells and sorted alphabetically. For department 2, I get Anderson, Perry, and Summers, and so on. Now, since I'm partitioning by department number and there's no order by, it gives me the total sum for the whole department. 59 for department 1, and all 3 rows with department 1 is 59. All the rows in department 2 is 25. Why 59? Because it's 22 plus 12 plus 25 of the 3 salaries in there. So I'm summing the salary over the entire partition. That's the key here. So what do I have here? There are other ways to do this again, and this one could have been done another way. You know, whenever you want a subtotal over for a whole partition, you could have used a group by. We could create a view with a group by in it, or an inline subquery with a group by in it, and then join that to the original employee table and get a report like this. That's another way to do it. So you can get this in other ways, but that's much more of a workaround and will take much longer again. Okay, so order by with no partition by gave us running totals. Partition by with no order by just gave us the total for the salaries. Now let's take a look, and that's the total for each partition, each department. So let's take a look at that one, and I have that code in here, and that's this piece of code that we just did. I'm going to run that, and sure enough, I get for department 1, it has my salaries, and then I have sum of the salary over partition by, and I got the total salary here. Now let's think of what else, what can we use this for besides the total salary? Well, one of the things you can use it for, it's a very interesting and nice additional feature, is I could say what % of the department salary does each employee represent? Well, that should be pretty easy. Do-Right is salary is 22, total department salary is 59. I have to take 22 divided by 59. I have to take the salary column divided by the total salary column and multiply it by 100 to change it from a fraction to a %. So that's what I'm going to do right up here. I'm going to say 100 times salary divided by, and then I'm going to take the whole expression here, which is my sum of salary over partition by department number. Of course, I would have liked to have taken the column alias, but as you know, you cannot use a column alias anywhere except in an order by clause, so it cannot be used here in the select list. So I have to copy and paste it and replace it. So let's look at this one, and let's run this one and see what we get. And notice 22 over 59 times 100 is 37%. The 12 represents 20% of 59. The 25 represents 42% of 59. If you had 37 and 20 and 42, and all the fractions, you're up to 100%. So this is really a cool capability because not only can you get totals for department, you can get percent of total. And it's very easy to get it. Very simple and very efficient. Okay. Let's go back to the order by clause. I just gave you one very simple example. I see a hand raised. And let me see if there's any chat in here. Okay. Nope. I will. I've got like 100 people in here, so it's going to be difficult for me to address each of those questions. And what you need to do is send a chat message, and at the end, hopefully I can look at the chat messages, but we may be having problems with the chat messages too, so I apologize for that. I will give you my email address at the end of the presentation as well. We'll go back to that, and I will make sure that you can email me with any questions since we don't have that capability right now. And we'll try to answer all of the chats, and I see Dave sent a little message out also that we're going to both try to answer any of the chats. But for right now, I'm just going to go on with that, with the presentation. So I'm sorry I can't kind of pick up and answer these as we go, but there are a lot of people in the group anyway. That will be very hard with so many people in the group. But we will get the answers back to you. Okay, so let me continue. I did a basic order by, but let's talk about the order by in more detail because it's got a lot more capabilities than just doing a simple running total. So let's look at it. There are two distinct possibilities here for my order by. The one reason is defining the rows, the order of the rows. When we did an order by, and we gave it a column, and we said we're going to give you running totals in that order. So that's one of the reasons. We've seen that already. The second reason, which we've seen it, but we really didn't realize we saw it, is defining a default window. And what is a window? A window is what rows are included in our running total, what rows are included in our sum, what rows are included in our average. Whatever our function is, which rows do you want to include? That's the window. If you don't have a window, the order by defines the default window, which is the current row plus all preceding rows. So the current row plus all preceding rows, that's the default window. And let's go back a few slides here where we had our first one. This says sum of the salary. Notice there's no windowing clause. All we have is an order by clause. So the order by clause, the default window is the current row and all previous rows. For this salary, let's rush April. Since there's no order by, it says I want to and sum of the salary gives me my 28. That's why this is a running total. 22 plus 12 plus 8 plus 8 gives me 50. It's always the current row plus all previous rows since I'm doing the sum. If it was an average, it would be an average of the current row and all previous rows, and I'd be getting an average instead. Same thing with min and the same thing with max and so on. So it's the reason that that running total worked was because the default window is the current row plus all preceding rows. That's what we didn't kind of realize before, but that's what happened. It's optional for many functions. It's normally used, but it's optional. It doesn't have to be used. If there is no order by, then the sum or whatever you're doing turns into an aggregate function. And that's what we saw here. The slide before, remember, had a partition by with no order by, and therefore what the function, the sum of the salary, really became the equivalent of the aggregate. It was the total for the whole partition, since we didn't have an order by. Okay, so this kind of explains why we got what we got in the last two. So let's move on, and now let's do what this was really intended to do, which is you can have a partition by and an order by. So here, I'm going to sum the salary. Okay, that's pretty cool. I'm going to sum the salary here, but I'm going to have separate partitions. Every time you hit a new department number, start the sum over again. Treat each partition differently. But within partition, I'm going to order by last name. So I partition by department number, and therefore my high order for my order by should be department number. And then I'm ordering by last name, and that should be the second sort. Whatever your partition, that should always be the first sort. Whatever the order by should be the next sort. In general, that's how you want to work. So now what do we get? I am partitioning by department number, so I sorted by department number. Here's all my department all my department ones, then all my department twos. And within department one, I'm ordering by last name, do something else. You should have sorted by department number first and then last name. If you sort, don't do that, you get something that works but really doesn't make any sense. So be careful with your order by clause. Make sure it orders by whatever you're partitioning first and then what you're order buying next. Okay. So let's move on. Before we move on, we have covered the partitioning by clause and the order by clause. There's still a windowing clause and some really sophisticated other things like ranking and so on that we're going to cover a little later. Dave, are you in yet? Can we hear you? I guess not. We still have that audio problem. So all I wanted to do was tell you a couple of things. This this webinar on analytic functions is just one chapter in our advanced SQL queries class. So we have an advanced SQL queries class for Oracle 10 and Oracle 11. We have one scheduled for July 26th and 27th. It's 2 full days of similar to the webinar, but it's not really a webinar. It's a full hands-on class. All the students.
Welcome to GoToWebinar, web events made easy.
We limit the class to 6 students because we find that that's the most manageable and we can get the best results from that. You'll have the two-way voice with me at all times, as well as your chat messages and so on. And you'll have hands-on workshops. All the kinds of things that we've been doing will be assigned as workshops. You will get to do them, and I will be available during the workshops to look at your workshop. If you have any problems, you can ask questions and so on. So this is the best way to teach without being in person, and we can get people from all over the country and all over the world coming in to that kind of class. So it's a hands-on web-based class. If you want to register, here's our website, www.skillbuilders.com/online classes. You can register for that. And here's our phone number and so on, so you can call up and register in person if you need to. We will be make available on our website this presentation and all of the labs that we're doing here, so you'll be able to download those and all the solutions, all the things you see me doing that I'm giving exercises on and I'm running through. You'll have all of that code as well, and you'll have this information. And just to take a look, when you go online, you will see we have our online classes. This is our advanced SQL queries for Oracle 10 and 11G databases. It's a 14-hour online class with hands-on. I will be available the full time. Can't be in your living room, but this is the closest that we can get to it. All you have to do is click on the Enroll Now. It's in July, and you will get a 250-page course book, headset, workshop solutions, the whole thing to make this a very productive class. And as I said, this is advanced SQL queries, which includes a host of other topics. I mean, here's our topic summary. We've got sophisticated things you can do with decode and case and set statements. All the subqueries we looked at, very advanced information about subqueries and correlated subqueries, all the advanced joins, partition tables, grouping data, analytic functions, the model clause, the connect by queries. I can go on, but it's an advanced SQL class. That's the whole point. Okay? So that said, that's the end of my little marketing chat, and let's go on and finish up what we're here to cover. And the last piece of the clause is the windowing clause. It defines the start of the rows and the end of the rows that you're going to analyze in your analytic functions. There are 2 types of windows. There's row windows saying how many rows, or range windows saying what's the range of values that you could have here. So we're going to see both types. The range of values is particularly powerful. So let's take a look. Let's look at the rows clause first. This says select last name, department, salary. I'm going to sum the salary like we did before, the partition by department number, order by last name, nothing new there. But now I have a windowing clause. So instead of the window being the current row plus all previous rows, the window is only one preceding row. You can do row 1 preceding, 100 preceding, whatever you want, or following. So notice, here's my salary 22. There is no preceding row, so my total is 22. Here's a salary of 12. There is a preceding row 22, so my total is 34. Nothing new there yet. But look at the last one, the next one. In Department 1, I get a salary of 25. It's one preceding row, so it's 25 plus the one row 12 to give me the 37. It's not all preceding rows, which it would have been if I only had an order by clause, because remember, the default window for an order by is all preceding rows. You can override that and say how many rows you want to proceed with. Okay. This is of some use sometimes. I don't find it particularly useful with the rows, but the range becomes very useful. Here's a different example. I'm also going from the employee table, last name, hire date, and salary. I'm averaging the salary over order by hire date. So therefore, I have my order by hire date down here. So it goes in hire date order. I'm displaying the salary, but I want the average salary, ordering it by hire date, range 365 preceding. Since I have a range, it says go back 365 days, basically 1 year, and show me the average salary. Well, Anderson was hired in February of '94, had a salary of 8. No one was hired before Anderson, so the average, of course, over the Anderson and the previous year is just 8. But now let's look at Washington. Washington has a salary of 12. Well, Washington was hired on April 21. April 21, '93 goes back a year, 365 days, to around April 22nd or something, '93, and therefore Anderson was hired in the last 365 days, so you get 12 plus 8 is 20 divided by 2, and you get your average, which is your 10. Now let's take the next one. August 2nd, there were 2 people hired on August 2nd, Do-Right and Wells, at 22 and 25. Let's see what they're going to add. The last 365 days, okay, is all of these people. So it's Wells, Do-Right, Washington, and Anderson. Add up all of those 4, divide it by 4, and you get 16.75. But let's look at Barbie down at the end. January '99. No one was hired in the 1 year before Barbie. Therefore, Barbie's average is just 12 because it only averages a range of 365 days before. So this is really nice in that you can see, all right, I'm trying to look at everybody's salary and compare their salary to all of the people that were hired in the last year to see if you know, there are anomalies there. Someone was hired way too high, way too low, or whatever. Again, this is the kind of analytic functions to do to do analysis of your data that you may want in more sophisticated analysis situations. Well, beyond the 365 days, Oracle has given us some really nice features. For dates, they have a range interval. You can say how many days, how many months, and how many years. I'll show you one example. Let's say I don't want the last 365 days. I want a range between 6 months preceding, 182 preceding and 182 following. I could do that, or I could say range between interval 6 month preceding and interval 6 month following. That's really what I want to do. Now, there's something else in here besides the interval. So this is nice. This will give me everybody's salary and the range of salaries of everyone hired 6 months before to 6 months after them. So you can compare their salary to people hired within a year, 6 months before and 6 months after. There's a special syntax called first value and last value, and we're going to show that in this example. So let's go to our examples, and I have that example right here, and let's run that. Here's Anderson, hired in February 194, salary of 8. I want to get the average salary of everyone hired 6 months before. There was nobody hired before. 6 months after February 1 brings us to August 1. So the August 2 doesn't get added in there, just the April 21. 8 and 12 is 20 divided by 2. I get an average of 10. Let's now take Washington. Washington was hired April 21. 6 months before includes the February date, right? So the February is the first date, and 6 months after April includes the 2 August dates, but not the March. So basically, we're taking these four and dividing it by 4, and we get 16.75. But even more important, look at the first value and the last value. For February 1, there was no one before, so the first value, the window start, is the one hired on February 1. The last value is the April 21. For Washington, the first value was February 1. That's within 6 months before. But the last value is August 2. That was the last one within 6 months. A lot of people get this confused, first value and last value. They think if you're doing a 6 month interval, it's exactly 6 months before and exactly 6 months after. That's not the purpose. The purpose is to show you the record that's included in the window from the windowing clause that's between 6 months. It's the records within that 6-month range. So here's that record, here's this record, and it shows you for this row. Let's take another one, March 15th, 95. Well, there is no one 6 months before, there's no one 6 months after, and therefore the range is only from March 15th to March 15th. Down here, August 97, August 15th, 97, there was no one 6 months before, no one 6 months after, and so on. But up here, obviously, there were people. On the April, there was people way back to February and up to August. Okay, so that's the point of the first value and the last value. So you're getting a feel for all these capabilities. I know in any webinar like this, you know, it goes pretty fast, and you get the goal is to get a feel, have you understand what this is doing, and then we will give you, as I said, the presentation. You'll have the presentation. You'll have all of the code that we have here, and you can go back and look at the syntax and get the syntax right. But our goal is to make sure you understand the capabilities here. Okay. Now we've talked about all three statements. We've got the partition by, the order by, and the windowing clause. All three clauses, we've covered them. What we haven't covered is some of the nice functions. All we did was sum and average so far, and we know what those are all about. But there are more sophisticated functions that Oracle supports in these analytic functions. Two of them are dense rank and rank. Dense rank and rank. Now, what does that do? Notice what we're doing. Partition by department number, order by salary descending. Therefore, department number is the highest level sort. Salary descending is the lowest. So I've got all my department 1, 1, and I get my salary 25, 22, and 12. Okay? So I've got that right there. Then I have my department 2, 2, and 2, and my salary 9, 8, 8, and 7. There's another 2 over here. All right? And let's look at my ranking. Well, the dense rank says this is the highest salary within department 1, the second highest, the third highest. Now I have a partition by clause, so therefore I start over again with my ranking. Within department 2, this is the highest paid, the second highest paid. This person, Summers, is tied for second place. And dense rank says the fourth place person is really a 3. Don't skip the 3. That's what a dense rank is. That's the difference between dense rank and rank. When there's a tie, the rank goes 1, 2, 2, and then skips 3 and says this is really the fourth highest person, even though, because 2 people are tied for 2. So some people in analysis, when they analyze the data, they want 1, 2, 2, 3. Some people want 1, 2, 2, 4. You've got both depending on how your client wants to see the data displayed. But this is very nice in that it does the ranking for you. So that's a really nice feature. And again, all these things you can have SQL workarounds to get them, but they're not pretty and they're not fast. This is much prettier and much faster. So let's go look at that one. We'll come in here. I'm going to I have to insert an extra row in the table to make sure I get some duplicate data, and I'll run this. I get matches, and sure enough, when I run this down here, let's look at it. Department 1, in decreasing salary, dense rank is 1, 2, 3, rank is 1, 2, 3. Dense rank is 1, 2, 2, and 3 for dense, because Anderson and Summers both have a salary of 8. And then this one is 1, 2, 2, and 4 for our ranking. Okay, so ranking is enough. And when you look at all the functions, these are the kind of sophisticated functions they have. Besides just the aggregate functions of sum, min, max, average, and so on, and count, the analytic functions get much more sophisticated and get into things like ranking and dense ranking. So you've got a lot of additional capabilities. There was also one that's a row number. Here, we're selecting row number, and all row number does is assign the row within each partition. So it assigns the rows 1, 2, 3, 4, 5, 6, starts a new partition. 1, 2, 3 starts a new partition. 1, 2, 3, 4, and so on. And the advantage of that is for that column, I've got department number, last name, salary, and for the row number, I can give that a column alias of row num, And then I can do that in a subquery, and I can say where row num less than or equal to 2. So if I want just the top 2 players in each department, I can get just the 1s and 2s. So that's like the top 2 earners per department. Unfortunately, this does not catch the case with ties. If 2 people are tied, it'll just give you one of them randomly first. But in a lot of cases, this is very useful anyway. So we have ranking, which we did on the previous page. And then we can have row numbers, which we can use to select just the top N people in each department. And there are other ways to do this.
Unmuted.
Okay, one last thing is lead and lag. I get a little echo here. Sorry about that. Did someone just come online?
Hi, Jeff. Can you hear me?
I can, Dave.
Well, how about that? I finally got connected to the audio. Sorry for the delay, but I've been answering as many questions as I can in the chat window.
Okay, terrific. And any others that we can't, we can capture that chat and then respond back to you afterwards.
Correct.
Terrific. Very good. Okay, I have we've got 10 more minutes. I have one more topic to cover, and then just a little summary, and then Dave, I'll turn it back to you to sign off on.
Thank you, Jeff.
Is that okay? Or is there anything else you needed at this point, Dave?
Nope, we're all set. Thanks very much.
Okay, just mute yourself. I'm getting a little echo. Thanks. Okay, very good. The last topic is the lag and the lead. Here, this allows us to look at rows that are 1 row before, 2 rows before, 50 rows before, 50 rows after. Lag, obviously, is before. Lead is after. So look at what we're doing. We're doing a little salary distribution by title. So I am going to sort my order by title and then salary. So here's my data by title. Here's the first account. There's only one. I have 3 designers, and their salaries are 12, 22, and 25. And what I want to find out is, okay, within the designers, I want to see what's the distribution of the salaries. Where are there big lapses, big differences between a designer at one salary and another salary? So what I want to do is, for my last column, I want to do the salary difference between this designer and the next highest paid designer. So what I do salary minus lead. Lead means the one ahead. Lead, the salary, 1 row ahead. I could do any number of rows I want. And this says, hey, if there is no 1 row ahead within the partition, just return a null. So I'm partitioning by title, order by salary, and that's my salary difference. So I'm doing salary minus lead of salary over my partition. So let's see what that does for me. Well, the accountant is a 10, but that's the only accountant. There is no one in the lead position. There is no accountant following Roger, and therefore we return a null. So that's what it is. There's no salary difference there. We're just returning a null. Here, for designer, there are several designers. The first designer is making 12. So 12 minus the salary for the very next designer minus 22 says, hey, this person, this designer is making 10 less than the next highest paid designer. Maybe we have a problem there. There's too much of a difference. Whereas this designer is only making 3 less than the next one, which was 25. And this is the last one. How much less than the next one? There is no next one, and therefore we return a null. So you can do all sorts of lead and lag analysis. So this really gets very sophisticated when you add in all the capabilities. Okay, there are a lot of other functions in there that I haven't covered, but just some closing thoughts. Analytic functions can be used in several places: in the select list, in the order by, in an inline view, in the from clause, but not directly in a from. You have to use it in inline view. Not directly in a where, a group by, or a having. So there are some limitations. You know, maybe Oracle 12 will release some of those limitations, and you'll get some more capabilities. But those are where it can and cannot be used. Here's a list of the primary analytic functions, and this has been expanded. There are many more, and the full list, let's see, is down here. Here's a full list of all of the current analytic functions. We've got average, correlation, count, cumulative distribution, first value, last value, which we've seen already, entile, percentile rank, regression, standard deviation, variance down here at the bottom. So there's a lot of different things that you can do here. We've just shown you some of the main ones. But anytime any of your analysts need to do more sophisticated analysis, you can do a lot of that right with analytic functions. Some additional resources that you can get, we also have provided for you. There's a very good book, Expert One-on-One, which goes into a whole section on analytic functions. Of course, the SQL reference and the SQL data warehousing guide is also very good, because in data warehousing, as you probably know, there's a lot of analysis that goes on, and it's an important issue there. So I want to thank you for listening. This is our phone number. That's my email address. You can address any questions that didn't get answered to that. And Dave, I will turn it back to you at this point.
Well, great. Thank you very much, Jeff. Fantastic presentation. And thanks for working through the audio problems that we had. And ladies and gentlemen, we'd like to remind you that we are running a class on July 26 and 27. An online class that Jeff will be teaching, and you'll have two-way audio. As you can see, it's limited to 6 students, so we do encourage you to register soon. There's a lot of attendees here, and we assume that that's going to fill up very quickly. In addition, don't forget, SkillBuilders also provides consulting services, even micro consulting. So if you have a project that you're working on that you feel that you could use a few hours of assistance to fast track some answers using analytic functions or any advanced SQL or Apex or anything Oracle, we're here for you. So thanks again, Jeff. It was a fantastic presentation. We appreciate all of the attendees who joined us today. We hope to see you again soon in a future presentation, and we will send you a link to the recorded version and the slides for this presentation and a download of Jeff's examples. Thanks very much all. Have a great day. We'll see you in the next webinar very soon.